Find me if you've lost your cell phone, or I'll just add it to my collection. I think it's the second one so far. Hopefully, I'll be at 4 or 5 in the day. And
Oh. Okay. So I'm Henry. Robert's going next. Okay, it's all good. Okay,
name wrong?
it's all good.
I apologize. I just had a baby 2 weeks ago, so I'm a little sleep deprived. That's my excuse. Bye.
Okay, so open source. This talk is going to be non-technical. So we're gonna go into open source. Right now we're in the age of GitHub, and we've gone through a lot of things as a community. The end of the world, right? Webpad happened. Microsoft is the top contributor in open source now, and we don't have. One of my friends, Sunil, he'd been asking about. I was process for managing burnout. As I work at Behance, which is a part of Adobe, and yeah, I'm a maintainer of Babel. You might know Babel through using certain features. Yeah. All right, so let's get into it. How do we interact with? Sometimes we complain on Twitter. But I guess the problem is that there are a lot of trade-offs for open source being online. Open source, the fact that it is online helps because we're able to get contributors from all over the world, but it also means that we're not able to meet face-to-face unless we go to a conference or attend meetups, but not everyone's able to do that. So it's interesting that as a maintainer you can feel so detached from the community but also connected. It's easy to make a lot of assumptions about projects and open source. So for Babel, right, you might make an issue and you might think, oh, this person's too busy to help me, or Babel must be a company that I work at, or that all these top companies are using it, and there's thousands of contributors making this thing better. And then when I contribute, it has to be a perfect PR for it to get accepted. And the people that actually maintain this project, they must be like perfect people. So like I said, it's weird that we're so connected but we're isolated, because I see like this notification pop up or on GitHub issues where in the current culture, right, we're all getting notifications and all these things about instant gratification. We're checking our phone all day. I think we're almost too available. We're always on call, and so that leads to a lot of expectations for maintainers. So maybe you join the Slack room and you expect people to respond in like 5 seconds, or even better, you join the room and you post an error and you expect us to figure out what the problem is. So if it works, there's like silence, right? Because it works. It's totally fine. It works 99% of the time. But then once it breaks, what happens? You get an issue that says there's 249 comments on there. Wow. This was this week. So yeah, don't read the comments, because what's going to be in the comments? A bunch of +1s and emojis. No, right? No. Or even better, just the same thing over and over. And this isn't even like my project. This is someone else's project. But what if what if it was the opposite? What if people made issues and they commented on it and they said it was awesome? That seems really weird, right? So what happened was Liam, he published a new version of a package, and then he went to sleep, and he woke up and he saw all these people commenting on his project. but I think he handled it really well. He made an issue to add test coverage, to do beta release, to add more maintainers, apologized, lots of conversations so there wouldn't be 1,000 comments, and was able to deal with that situation. That actually happens a lot. So what are the responses that other people had when they saw this? Of course, someone said, it's left pad all over again. And sometimes I get frustrated too. Like, it's hard to deal with these kinds of issues all the time. But even worse than that is when I see people online saying that they don't want to contribute to open source anymore because that's what they think it's normally like. So yeah, the fear is real. There's a lot of guilt, there's a lot of problems with maintaining a project. For example, just simply GitHub issues. It's really hard to like close someone else's issue, because if you close it, then they'll feel like that you just insulted them by like not listening to what they're asking for. For each individual person, that issue is the most important thing in the world, and if you close it, even though you're looking at 1,000 issues, people take it personally. You might have heard the phrase before that saying no is temporary, but yes is forever, and I think that does apply to open source. When we say no to by closing an issue, but knowing that it can be reopened at any point, you can still say yes in the future. But if we say yes to a certain thing, you're going to have to maintain that thing for forever unless we deprecate it or remove it entirely. So there's inbox 0. There's also, I guess, issue 0. There's this weird thing where we want to like close every issue or figure out everything, but it's like literally impossible for that to happen. I think Chromium has 50,000 open issues. And releases, just releasing a new version can be stressful. Or you can see this by how I've tried to release things. So there's this project called Lerna, and it took us a whole year for us to decide to make a 2.0 and 38 betas. You think that by that point you figured out like what's a beta, right? And Babel 7, that hasn't even been released yet, but we made 20 alphas because we're not sure what is Babel 7. Like, it just became this thing where like things, feature creep, fear of breaking things, fear of breaking the community, and even deprecation messages. You think that this is not really an issue. So I made Babel preset env about a year ago, and last week I decided to deprecate preset 2015 because it replaces it. And it took a whole year because I wasn't sure what the response was going to be, and maybe we didn't want to just like say all this stuff. This package actually gets $5 million a month, and then we got a lot of people kind of frustrated, but it was interesting to see people seeing how deprecation measures can be like human. So yeah, there's a lot of issues, but and we want to make open source inclusive and welcoming to other people. So what can we do about that? This is just some ideas that I'm still trying to figure out myself. So we might think about entitlement, right? Our users aren't paying for it, and they feel like they need to deserve something. What do we deserve? What do we expect out of other people? But how do we respond with that? But it really just goes both ways. Maintainers can be entitled to, obviously. And to go back to the title, maintainer heal thyself, referencing Luke, where it says physician heal yourself, to say that you have to prove to yourself, to other people, that that you're worthy and up to the task. That if you're a doctor and you have the same problems as other people, then people won't be able to empathize with you, to be able to understand what you're going through, or even want you to help them. So it's kind of like the phrase "charity begins at home," where you want to take care of yourself before you're able to take care of others. And I took the plane ride to get over here. It reminded me of like when we go on the airplane and tells you that you should put on your own oxygen mask first before helping others. And similarly, it's really easy to be a hypocrite. It's really easy to tell people what they're doing is wrong and then not see that what you're doing is the same or even worse. We have to learn to, just catch ourselves when we end up doing the same things that we don't want to become. It's important to remember the freedom that we have in open source, that if you're not getting paid to work on it, then there really isn't anything to lose because you have a job and it's not your responsibility to make this project be sustainable at the cost of your health. That there's a freedom to step away, and that's what makes it so amazing in the first place. But what happens is that you get trapped in your own mind that you have to, you're bound to this thing when really you're not. One thing I've been, learning is trying to appreciate working on something for a really long time and finding a joy in pursuing a certain, vision or purpose other than just going to the next thing every day, and looking at the big picture that the passion can lead you to finding something, but it won't sustain you. Another thing is to see everything as a gift, that we're all privileged to do open source, and if we see that it was a gift, it was given to me, then I don't have to think that I deserve anything because of it, then I can do it with gratitude. What that means is that, I want to kill the pride that I have in the project that I work on or the hobbies that I'm doing. I want to be spending my time serving instead of serving myself. So, there's a lot of lies that we tell ourselves when we're doing something like this. Really basic one is to think that we're really indispensable, that we're indestructible, that my identity is based on my work. I think since so many projects are just 1 or 2 people, you might think to yourself, if I stop working on it, then who is going to work on it? If you leave, the project is dead. It's hard to remove the idea that the whole world depends on you, and you don't want to disappoint anyone. But you have to, it can be hard to do that after you've been working on something for a really long time. You stop thinking about your health, you don't sleep, you have to realize that rest isn't an optional activity, it's a necessary thing, right? And that the ups and downs of life are normal, and you're able to get through that. People can call you the X person, vowel guy. People start referring to you in a certain way, and then you might think that that's who I am, and you have to prove over and over that that's who you are. So that's what we can do as maintainers, but what can we do as a community? I think one thing we should do is try and stop trying to one-up one another, and to act in a way that people will not want to emulate you, that we can't respond with the same entitlement, hostility, and aggression, because that just breeds the same behavior. Another thing that we do a lot in open source is focus on the code, the commits, rather than everything else related to an open source project. We ask for contributors to make PRs, but knowing that there are a lot of other parts of open source that we could be working on, whether it be design or documentation, tutorials, videos, mentoring other people. And another thing that we have a problem with is short-term thinking. Thinking that a project is all about the hype and not about the many days, weeks, months, years of work ahead. And another problem is that the contributors that we might have had don't feel empowered, right? That the whole point of open source is that everyone has the ability, the capability of contributing back, but yet a lot of us don't use that ability. And you might think it's like if you build it, they will come, but we could do a lot more work in trying to guide people and mentor people. Yeah, one thing that happened with me, at least, and I'm sure a lot of people, is that the way I got started with open source and through maintaining Babel is that I didn't like decide one day I was going to become the maintainer or anything, right? It kind of just happened, right? You kind of get involved, and then slowly other people go away, or they get burnt out, and then suddenly you realize, you wake up one day and you're like, wow, I'm the maintainer. And then you're like, wait, what are we supposed to do now? And you're like, so yeah, I think the problem is we don't have any supporting structure. There's no project managers. There's no, you're everything, I guess. You're the project manager, you're the coder, you're the leader, but you don't really know what to do. And there's no place to encourage people. People might say like, oh, I'll start your project, but stars don't mean anything, and it's a one-time thing. Yeah, I think if we did have a place, where you could encourage one another, I think that would be great. One example of this, another tab to talk about how they appreciate projects. And I think GitHub is doing a lot of good work here recently. They have this program called Open Source Friday. It's an effort for getting projects and companies more involved and to contribute to open source on Fridays. There's a new repo for maintainers for them to talk to one another about, I guess, issues or things they can improve to collaborate with one another. And GitHub also made this nice website called opensource.guide. It goes into a lot of different areas on how to contribute, how to maintain a project, etc. So another thing is funding. So Babel, right now, Babel has about $20,000 a year through a website called Open Collective. It's kind of like Kickstarter or Patreon. It's a way for the community to fund a project. The highest donation we have from a company or individual right now is $100 a month. And yeah, so $20,000 isn't enough for anyone to work on any project full time. So right now, Babel is a handful of contributors and mostly volunteer. The only people that are paid to work on it right now is me, half the time at my work, and then Justin, he's working 20% time at Google. So what can we do? We can do what we're doing at my company, where we hire people to work on the projects that we're using to make sure that our company isn't influencing the project in too much in that direction, to have that neutral governance, but then also to know that the company is going to influence what's going to happen in the future. And maybe that also has its own issues, right? Maybe if you're working on halftime, then I have to spend, when we need a feature out, then I might have to spend more time working on our site, and then when there's downtime, work on open source more. It is possible to support maintainers full time. So Webpack, they're the most successful open collective right now. They have 200,000 a year now. They're able to, the creator was able to work on it full time pretty recently, which is awesome. Or you can go the other route. Patreon is for individuals. Evan, he created Vue.js, and he's able to get enough to sustain himself too. So yeah, basically let's rethink best practices, but for open source. Is the way that we're doing open source now actually working? Even though like all these companies are using open source and people know about it, people know what GitHub is the way that we're actually doing it now sustainable? I think we have an opportunity to be an example to other communities that deal with some of the same issues with like burnout and being just work in general, medical field, other things like that. I think we can learn from them, and then we can also teach them as well. So I just asked that you join me in making open source sustainable. Thanks. Okay.
But yeah, we'll move on to Robert for Realist Time from Facebook.
Thumbs up in the back. How's everybody doing? Oh, okay. Welcome. This is GraphQL subscriptions full stack, and the first slide is mislabeled. I'm Robert Zhu. I'm a software engineer at Facebook, and I work on the GraphQL team. And I'm here to talk to you about GraphQL subscriptions today. Since a lot of you use React in your day-to-day work, you've probably heard of GraphQL, but if you haven't, don't worry, we're going to do a quick intro. Here's the agenda we'll follow. We're going to do a primer on GraphQL. We'll talk about the basic operation types. We'll talk about what it is and what you can do with it. We're going to dive in very quickly into subscriptions. Now, most people who use GraphQL, you're familiar with the concept of queries and mutations, but subscriptions is a little bit weird and it's a little bit different. So we'll talk about what they are. We'll talk about why you would want to use them, how to use them, and then we'll dive into what you would do if you want to build your own subscription server. And if you get really successful, how do you scale that thing? We're going to be going through a couple resources as we go through the presentation. And I'd ask you not to bother taking pictures of it. I'll have a resources slide at the very end with all the URLs that you can follow through. So take a picture of that at the end if you want. And then while that's up, I'll leave a couple of minutes for Q&A. All good? All right. So those of you who have your laptops here, I'd ask you to follow along. I think it's a really cool demo. So just go ahead and open up your browser, navigate to graphql.tk. Yeah, and if you want to grab your laptops and follow along, I think it's really cool. I think it's really fun. Can everybody see that okay, or is the font big enough? Yeah? Okay, anybody need more time waiting for their laptops? Want to follow along? Raise your hand. Okay, just a couple more seconds. I guess I'll start talking about this while we wait. So what we're looking at here is graphical. And graphical is the GraphQL IDE. With graphical, we can author a GraphQL query, or what we call a GraphQL document, on the left-hand side where the cursor is right now. We'll package that document up and we'll send it over to the GraphQL server. The server will process it and assemble the responses back into a JSON string and send it back for us to display in the right-hand panel over here. There's this handy docs link on the right, and if you open it, you can explore the schema that this particular GraphQL endpoint is built on top of. So right here, we've got the documentation explorer, and it's saying we've got 3 root types: queries, mutations, and subscriptions. I'm going to take you through queries and mutations because we need those concepts to build up to talk about subscriptions in an intuitive way. So the first thing I'm going to do is click into this query type here, and it says there are 2 root fields, house and houses. So if I click house and click through here, I can see house has 3 fields: name, bannerman, and words. Can anybody guess what this GraphQL server is exposing? Game of Thrones. I want to talk to anybody who cares to talk about the season 7 finale after this, but let's use this as a GraphQL endpoint. Check this out. So if I just come in here and type query, and I follow it with a pair of curly braces, and then I type houses, and I say I want to get all the houses, and I want to get the names for each house. And I click Command Enter. This is the response I get. As I promised, on the left we have this thing that kind of looks like JSON, but you have the values stripped away. What's left are the names, and that's our GraphQL query. We send this over to the server performs some magic, and we got back JSON on the right. This has the names of all the houses. But I can see from the Documentation Explorer, I can get more than just name. I can get the words. Right? Our favorite, House Stark. And we can even get the bannermen. How many bannermen do these houses have? All right, looks like Aaron's in the lead with 2. Martell also has 2. Tully has 3. Okay. So feel free to play around with that if you're bored by what I'm saying. All right, what did we just see? Well, we saw graphical, so clearly something is serving us up a web page at graphql.tk. Right? Let's just get the nitty-gritty out of the way. There's an Express server. Express, by the way, is the Node.js HTTP server. And one of the pieces of middleware it's hosting is graphical. But it's got a second piece of middleware that it's hosting, which is the GraphQL server itself. And it serves both of these. So what you see on the web page is when you go to graphql.tk, you get GraphQL graphical, the IDE, and then when you send requests, you're actually hitting a different endpoint on there. You're hitting the GraphQL server endpoint itself. So when we hit that play button, we're packaging the GraphQL document that you authored, and we're sending it over to the server. And the Express server is going to pull apart this HTTP request, take the GraphQL document out of it, and hand it over to the GraphQL server for execution. Now, when the GraphQL server gets a document, it goes through 3 phases. First, it parses the document. Second, it validates it. And third, it executes it. Each of these phases is distinct because the first phase applies a set of rules to check whether or not the GraphQL document you submitted is valid GraphQL language. Does it look valid? So for example, if I had written query and I followed it with a pair of square brackets, it's not valid GraphQL. I have to follow it with curly brackets, right? Or if I don't close the curly bracket, then I've got a syntax error. That kind of thing is detected by the parse step, which applies the domain-agnostic rules of the GraphQL language as defined in the GraphQL language specification. If it passes that, and it looks like a legit GraphQL query, then we have to do a further step. We move on to validation, which is it needs to check whether or not the selection you specified is valid with respect to a particular schema. In our case, our schema models the Game of Thrones world. And so we couldn't go and ask for spaceships. They don't exist in Game of Thrones, at least as far as we know, right? So you can't just go in there and type anything. Only some fields work, and some fields have some types have some fields, and other types have other fields, and then fields have relationships between them. And that's specified by the schema. Finally, if it passes validation, then it goes on to execution, which basically treats every one of those fields as a remote procedure call with arbitrary logic backing it, and the value that gets returned gets assembled into a JSON string. So the GraphQL document will take the following journey. It'll move on to validation if it passes parsing. If it passes both of those steps, then we try to execute it. And if we successfully execute it, then we've got a JSON string. And we hand that back over to the client in the HTTP response. Anyone with me so far? Yeah, raise your hand if you have questions, by the way. I didn't mean that the Q&A section at the end means that you can't talk. It's a little quiet. So, what happens on the client? Well, we issued that request and we got a response. Crack open the response and we have a piece of JSON. What do we do now? And the answer is anything, right? You could write a script and just dump this JSON into a file. You can shred it and put it into a database. You can put it into a piece of client-side state manager and have it declaratively re-render the view, which is probably what we're familiar with in the Flux architecture that React is built on, right? Or we could just process it by hand with jQuery. It doesn't matter, and you don't need a complex framework to do this. What GraphQL provides you is just a really simple endpoint that allows the client to declaratively fetch the data that it needs. Great. What about writes? We saw an example of a read where we fetched all of the houses and their names and their words, but a good API has to support writes as well. And in GraphQL vocabulary, we call writes mutations. And they have the exact same life cycle as a query. You have a request, you package up that document, you send it over, it goes through the same validation steps, execute it, and then you send the JSON payload back. The one unique thing I want to point out about mutations is that we tack on a read with the write. So a mutation in the GraphQL schema declares a return type. And the return type is the thing that you start querying after you execute the mutation. I think it all makes sense if we go back to the demo real quick. I'm going to open a new tab just so that we start from scratch each time and you can follow along. Okay? I'll open the docs again for reference. And I see here that under mutation, I have a single mutation called pledge. So I'm going to come on here in my editor. I'm going to type mutation, follow it with a pair of curly braces. And then as the root field, I'm going to type pledge. And what mutation is semantically telling me is that this is affecting a server-side state change. This is changing something about the data on the server. In this particular case, if I pledge to a house, the count on its bannerman increases. I'm sorry if you don't watch Game of Thrones, but it makes sense, trust me. Okay, so let's come in here and pledge to House Tully. And if I run this, I can actually specify the data that I want to fetch after I pledge myself. So one thing that might make sense if we keep going with this analogy is after I pledge myself, I want to know, did I pledge myself to a loser? Or, is House Tully getting really popular? I want to know how many bannermen are pledged to House Tully after I've pledged. And I also want a reminder of the words. I don't really know what their words are. So if I execute this, okay, somebody's been pledging to House Tully. Because last time we looked at it, there was like 3. All right. This is a precocious bunch. Okay, so this is really cool, right? Like we've just committed a write to the server, we've affected the state change, and we fetched the data that I cared about. I want to know what changed after I did this thing. And I also wanted some other data that might not necessarily change with the mutation I just wrote. So hopefully that's a good example of a mutation, and then you can, you're already doing it, so I'm not going to stop you from pledging to houses while I speak. But any questions about mutations? Yeah, right here.
Are all writes done as in sort of argument style, like inside a function? I imagine that can be kind of unwieldy if you're uploading a much more complex set of data.
Yeah, so that's a great question. For those of you who can't hear in the back, the question was, are all writes done as arguments here? And so the argument we have here is house, and we're specifying house Tully. And the answer is yes. So you must provide all of the arguments into a mutation when you are providing the write. Now, the server can fill out additional data. It can fill out something like a timestamp by itself. But if you're creating a new user, for example, there's some irreducible set of inputs that you need to provide. Perhaps you need to provide the email and the desired username, right? And that set of data must be provided as inputs. The thing that makes this, I'll just touch on this briefly, but you can make a mutation reusable by extracting the arguments that you pass to it as a variable, and you can define those variables down here in this window right here. Okay, any other questions? The back's really quiet. Please don't be afraid to speak up. What is that over here? Yeah. Let's try some error handling. Oops. All right. So this is a great example. I'm glad you asked that question. What we sent to the server appeared to be valid GraphQL, right? I've got the curly braces, I've got fields. I don't have anything that seems syntactically fishy. But when it tried to execute this thing, it gave me this really helpful message like, cannot query field ASDF on type house. That's because in the schema, the house type doesn't have that ASDF field, right? So you get a couple of types of errors. You can get the type of error that graphical tells you, hey, I don't think you've got a valid. That's right. So what you can do is, if you throw an error in your mutator, in the resolver back in the mutation, you can give a much more informative message. In this case, we know that it didn't execute. But yeah, the semantics of handling that are up to you as the API designer. Another question? Yeah.
What specifies that the return object is the house Tully versus your house, where there's multiple inputs, you have multiple outputs?
Okay, so the question was, in the mutation, what specified the return type?
Well, return ID, I guess. Like that, we're getting the definition of house Tully versus not your own house or whatever.
Yeah, that's a great question. So again, that's within your control as the builder of the mutation. So if we go and look at the mutation type here, and we say pledge, we notice that it returns house. So the semantics or I can also add documentation here or description here that might help you disambiguate and say the house that is being returned is the house that you just pledged to, right? So this isn't a way to avoid documenting your APIs. It's just a way to explore them and know the types that have to go in and out. But very good question. Okay. Moving on. Okay, we just did a demo. All right, let's summarize what we've learned about queries and mutations. We know that they're both request-response based. The client constructs one of these documents, sends it to the server processes it, sends it back to the client. We notice that the data that we want and the data that we get back is entirely client-driven. And this is a very powerful feature of GraphQL. Let me elaborate. When we empower the client to define the data that it needs, we address two problems that we call overfetching and underfetching. I'm sure many of you have used REST APIs, and I think there are two common occurrences when you deal with REST APIs. One is you fetch a resource, and because the server decided the shape of that resource, it might give you a bunch of data that you don't actually care about. And you go through there and you pick out the fields that you want out of the JSON response. We call that scenario overfetching because we fetch data that we didn't need. And the second type of scenario occurs when you deal with REST APIs that make great efforts to become more hypermedia compatible or more RESTful, REST-ish, and then when you ask, for example, a list of houses, you might get back an array of HTTP URLs. And then as the client, what do you have to do? You just have to issue subsequent HTTP GETs on all those URLs, right? And you might have to do that a number of times more before you get all the data that you need. That situation is when a single network round trip did not fetch the data that you needed. You actually have to follow it up. So that's an example of underfetching. And these two problems can occur simultaneously. You might get back extra data that you didn't need while the response didn't contain it that you did need. GraphQL sidesteps both of these problems. And why do we care? Like, why is that a thing? Well, if you're building your API, and that API is going to be shared between your mobile clients and your web clients, and your mobile clients happen to be lagging year class devices. Maybe they're targeting developing parts of the world, and these devices are on constrained networks, maybe sub-2G networks, or maybe they have data caps. You need to be really efficient about this because not only is this wasteful in terms of network usage, battery life on the mobile device, but it also makes the client-side error handling more difficult. As a client, you need to know, okay, there's 7 HTTP URLs, 1 for each of the houses. Let me issue these requests in parallel, wait for them to come back, and then I join them into some sort of client-side data structure. What if one of those houses came back with a 404? Right? So not only are you solving this problem from an efficiency perspective, but you're also solving it from a client complexity perspective. How are we going to handle real-time data? We saw that the Bannerman field changes. How would we build an app that displayed those kinds of updates in real time? I have an idea. Let me show you. Whoa, come on. Did somebody write a script to do this? All right. So
Is this app normal?
clearly,
This would be normal.
thank you. I appreciate that, whoever's doing that. All right, so cool. I've got my real-time app. Look, I did it. It's changing in real time. It stopped changing. What happened? Okay, so raise your hand if you've done polling. All right, yeah, everybody. So it works, right? No. Why doesn't it work?
You're overloading your client with both requests and with CPU.
Okay. Yeah, somebody's already overloading the server, but okay. So yeah, before we start moving on to the better solution that should replace polling, I just want to pause for a moment. Don't just toss out polling. Pause to consider it. If you're building something like a temperature sensor and your data is tightly structured that you want one sample of the temperature every 5 seconds, don't get fancy and put in a reactive streaming protocol in there because you just poll the thing every 5 seconds anyway. Just do that. It's going to be a lot simpler. So what can we do? What else can we do? Well, I mentioned that we have this subscription type here. So if I come in here and execute a subscription, let's see what subscription supports. Power changed. Okay, so it's saying the power between the houses has changed. I'll get the name, and then I'll get the Bannerman. All right. This is a pretty small server, so if you're if you're slamming this thing with requests, we may have a lot to talk about in the scaling section. Has anybody in the audience tried this just now? Okay, and is the same thing happening for you?
I just got it.
You've been getting live updates? All right. House Aaron? Okay. This is going to be great, actually. This is really good. Remind me to talk about the problems we're seeing here, if I don't cover them at the end in the Q&A. But this is really cool, right? Look, hands off the keyboard. I'm not hitting refresh, and it's updating. I think this is pretty cool. Yes, Aaron, go for it. All right. Let's.
Have you set up the order that they returned in on the server? Is that a
They're just, yeah, there's no sorting order right now. It just happens to be that I populated the list of houses alphabetically.
okay?
Yeah. Would it be cool if we sorted it by, it's a good suggestion for a feature. Okay, let's go back to the slides. All right, we just saw the demo. Hopefully that makes sense, right? We wanted to build a real-time app. We know that there's a bunch of mutations coming in very, very frequently, apparently, that's changing the server-side state. And we can get that update by polling this thing with queries. But the subscription is giving this to me in real time, and it's pushing this data down, so it's a little bit more efficient. So now that we've seen it in action, let me try to describe it in more detail. This is taken right out of the GraphQL specification. About GraphQL subscriptions, it says, if the operation is a subscription, the result is an event stream called the response stream, where each event in the event stream is the result of executing the operation for each new event on an underlying source stream. Executing a GraphQL subscription creates a persistent function on the server that maps an underlying source stream to a returned response stream. I wrote this, and I'm sorry. Okay, in all honesty, there's some pretty interesting stuff going on here. And this is the most concise way I can think of to write about a fairly set of interesting concepts that work together to enable subscriptions. So let's go into some visual diagrams to help us tease that apart. We mentioned this event stream a couple times, or this event system. So we'll begin just by trying to get everybody on the same page about what an event system is. There are many variations out there. You might have heard them referred to as pub subsystems, event buses. But imagine that we're building a service or an app that has these three components, very common. We have this account management microservice that allows users to sign up with an email and a password. When the user wants to log on, we have a session management service that issues some sort of access token with some sort of expiry date. And we have this messaging microservice that allows logged in users to send messages to one another. So you can imagine that when somebody signs up, I can build the account management system to publish that event of somebody signing up. Right? So somebody created an account, and I put it on the event bus, and I broadcast it to whoever cares. When that user logs on, I do the same thing. I take this login event, I may package it with some data, and I send it to this event system so that people who care can tune in. And then when that user sends a message to another user, something like that might happen. Okay, with me so far? Yeah, we might get another message. So far, we just saw a bunch of microservices publishing to the event system, but we haven't seen anything consuming from it. So what if I wanted to build a feature that says, hey, I want to detect suspicious logins. And what I mean by suspicious login is if somebody logs in from an IP address on 2 different continents in the span of 5 minutes, I might want to flag the account and prevent it from doing anything before I have to, really deal with some damage and undo some things, right? If somebody makes a fraudulent purchase, it's much easier to detect that and prevent that than to undo it. So the login, that event, the alarm microservice can say, I care about these login events. So when a login occurs, give it to me. I want to check it out, right? And it might say, okay, user with ID 123, they just logged in from Boston. Great. User with ID 123 just logged in from Argentina 2 minutes later. Whoa, what's going on? Let me flag this account and not let it. I might still give the account access to the service, right? But I might send the user an email, the owner an email, and say like, hey, we detected this login. Was this you? This is a pretty common pattern, right? A lot of people have experienced this kind of thing where, it asks you, hey, was this you who logged in here? Is this a trusted device? So that's what we're trying to build. And we can see how an event system can be one way to build this type of feature. That's what we mean by event system. So we've just taken the event system and moved it to the very top, and the box got smaller, but the concepts are the exact same. So what's happening with this subscription? When we're executing subscriptions, when I executed a subscription on stage, when you executed a subscription from your computers, well, there's a very similar flow. Before we start moving this diagram around, I just want to point out that this subscription server here, WS stands for WebSocket, because the example we just saw was using WebSockets to push these new data payloads down to your client. And what we're doing here is at the protocol level, we're saying we want to subscribe to this GraphQL document. And the semantics of a subscriber are different from request response. They resemble more of like a phone call where you dial someone up and you have a conversation. And at some finite time in the future, that conversation is going to end. So the client sends the things to the server, and the server parses out this GraphQL document, and it remembers it. It just hangs on to it. Notice that this GraphQL document has a chunk missing out of it, because this document isn't immediately executable, unlike a query or a mutation. Because what we're actually saying with this document is, when somebody pledges to one of the houses, fetch the following data. The first part of that sentence is a condition, when. When something specific happens, do this other thing. And when that something doesn't happen, we can't actually execute the document. So even if the server wanted to execute this document, it couldn't. So now we have this event system going on, and somebody pledges to a house, right? And the subscription server registers interest in a specific type of event depending on the query that it received. And it says, hey, this is a pledge event. I care about that. Let me check it out. And so it receives a publish, or it gets a callback because it registered as a subscriber. And when it combines the event and the GraphQL document, it now has something that's executable. And now I can give this to the GraphQL server, which can parse it, validate it, execute it, turn it into JSON, and send it back to the client. And notice that the state on the server, the state of remembering this GraphQL document in its incomplete, unexecutable form, is ready to receive the next event that comes across and do the exact same thing again and again and again. So let me, I forgot to mention, you might say, well, what's special about GraphQL subscriptions? It's not the event system. The event system is a very well understood concept. But the special sauce here is that you have a mapping for a GraphQL document and its variables to this set of underlying domain-specific events. So when we submitted that subscription that says power changed, something on the server must know that the power changed subscription needs to listen to these pledge events. If it didn't know that and these pledge events came in, it wouldn't know that it needs to re-execute this query, and it wouldn't know to send back the payload, right? So the special sauce is in this link right here of building the source stream. Now we can finally make sense of that spec language that we had a couple slides ago. This thing up here that I've replaced the event system with, this is what the source stream refers to. It means that we can take a GraphQL document and we can map it to a source stream. And the source stream might be something that's derived from the GraphQL document. It might be something that is polling underneath. Or it might be anything you desire. It's something that will issue a stream of events over time. And then the server, when it gets these events, can complete the GraphQL document and then submit it for execution. And those results are then passed over the response stream, which is that stateful conversation that the server has agreed to have with the client. Here's the subscription lifestyle. We've got a request. We send the document over to the server. When we subscribe, we don't just execute now. It's not that simple anymore. We derive the set of domain-specific events from the GraphQL document and variables, and we use that to construct the source stream. From the source stream, each event that's emitted is combined with the document, and then we execute it. And then we send the response back, the JSON response back. So if you want to build one of these yourself, here are the major building blocks that you should have in your mind. The first is that you need a persistent streaming transport. Right? The request-response interaction style is no longer sufficient to model this kind of interaction. You need a map that remembers which clients are connected, what their subscriber info was, because you probably still want to do authentication and authorization, and then you just remember the document that they submitted. You need that event system that we talked about, and there are lots of variants. Choose your favorite. And lastly, you need to have code that detects and publishes these events. If the resolver backing the mutation for pledging to a house did not publish to that event system, then there's no way that the subscription would have known to re-execute. So the system may need some changes on the right end. But we've crossed a very subtle but important line when we did this. We've introduced state into the system. When you go from vanilla GraphQL that supports queries and mutations, when you start with that and you just have queries and mutations, the GraphQL layer is stateless. And the way you scale the stateless GraphQL server is you just stamp out copies of it. You just spin up new EC2 instances or new Docker containers or whatever, and you just copy this thing again and again and again until it can supply the capacity that you need. But it's not so simple when you're dealing with the state anymore, right? It's a lot harder. And the state that we had, here's a list of it, but we saw this roughly corresponded to the set of building blocks there. But even the piece of, I've got a GraphQL document, I've mapped it to this set of domain-specific events, and now I subscribe to those domain-specific events. The fact that I subscribed to these events is state. If that information is lost due to single node failure, I won't get the publishes on those events anymore. So when we talk about scaling, it's useful I find it useful at least, to talk about what this looks like if you were to just build it as a toy, which we've done here. If we just built it in a single process, what did we do? What can we do? And then what does it look like to take that to a more mature architecture that is distributed and fault tolerant? Well, the first thing is that, and that's common between the single process and distributed model, is the streaming transport. You need something like WebSockets or SSE, or some approximation of a streaming stateful transport like HTTP long polling. You need to handle the connection. So when something does a WebSocket upgrade, something needs to handle that connection and hold on to it and say, yeah, you can ask for a WebSocket connection, that's cool. And the way we would do it in a single process is that we would just do it as a piece of middleware, right? The WebSocket middleware if you're using Express, but something similar exists for almost every popular web server these days. But if you want to do that in a more distributed way, know that a single process, any connection it's held open to clients, will go away if that process is taken down, right? If a couple more people started writing these scripts that voted for House Aaron, that process is going to go down, and everybody subscribed, their WebSocket connections would disappear. And that's why I think that example is so cool, because we're talking about this problem right now. I didn't expect to hit it in this demo, and I'm so glad that we did. Because the way how would we solve that problem, right? Well, the very first thing we know is we don't want a nasty user experience that's like, oh yeah, I mean, you've been disconnected. I don't know why. House Aaron's too popular, right? But that's a terrible reason. What you want to do is you want the client to terminate its stateful connection with a proxy or a gateway, right? And that gateway holds that connection. And that gateway scales the ability to serve these different connections. And it scales the ability to handle failover of those connections. Let's talk about the source stream. So in a single process, we can just do this with a Node.js event emitter. It's fine, and it's perfect. If you're using ASP.NET, just put it in a regular .NET event class. But in each of these cases, your subscriber is a delegate, right? It's a callback function. And a callback function is not going to survive if the process restarts. So all your subscription info is lost. If you want that to be durable, the first step is to move it out of the process. You're going to want to use some sort of distributed source stream, a distributed pub sub system. And I've just got a couple examples here. There are many, many more, but Redis, Kafka, I'm sure many of you have heard of these services. Amazon's SQS is a great one. Pusher is another great one that's really easy to use. And lastly, the subscription session data. So who subscribed, what's their access token, how long are they allowed to subscribe for, what document did they submit. You can store that in memory. That's what I'm doing in this demo. But if you want to be more resilient about it, you need some sort of distributed database or some sort of cache that can survive single node failures. Okay, any questions? Yeah, over here.
How do I unsubscribe?
Yeah, so the unsubscribe, unfortunately, we don't have a good way to do that from Graphical because the protocols in Graphical are the choice of protocol that you use in Graphical is so different. But the answer is that the unsubscription operation is not a GraphQL operation. It is a protocol level operation. Just as the subscribe message wrapped the GraphQL operation itself. So the answer is that it varies based on protocol.
Basically, I'm just trying to imagine a scenario where I close my browser and there's an open stream coming in from the service. And here I have like 100 users, big number that keeps leaking, that affects performance.
Well, if you close the browser, the handler. Oh yeah. Sorry. The question was, how do you unsubscribe? How do you cancel the subscription? And the answer that I gave was that it's protocol specific. And so in this particular case, in our Express server, we have a piece of code that's handling the onConnect event for the WebSocket connection. So we can also write a piece of code that handles the onDisconnect event. And that's what happens when you close your browser and the connection doesn't shut down gracefully. But good question. Yeah, here.
How does the GraphQL server talk to the underlying database?
Yeah, it does so however you want. Yes, sorry. How does GraphQL talk to the underlying database? And the answer is however you want. If you have a Mongo database, then you might, pull in the Mongoose driver and talk to it that way. The point is that the resolver code is just arbitrary code that you write. So you can do anything you want. You can read from a file. You can hit an HTTP endpoint. You can talk to a database. You can hit a cache. It's all up to you. Okay. Yeah, another question.
So when you demoed these subscriptions, for this example,
Yes.
The nature of those, I think the term you're using, source events, was such that the data had changed. The data had changed and you knew exactly why it changed.
Yes.
But a tool I've been using recently, which I like, is RethinkDB, which is it's sort of real time and it gives you this ability to
to be notified whenever the underlying persistence data changes, but not necessarily, you don't have to know exactly why it changed.
Yeah.
And it's not immediately intuitive or apparent to me if this could be scaled to that, like if that source event could be, somebody did this operation, not that, but instead, this data changed. Could you maybe hit on that if people sort of experimented with sort of extrapolating it to that level?
Yeah. We don't have that much time. Would you mind if I use that as the first question in the Q&A section? Okay. We're almost done. So I just want to cover really quickly what the state of GraphQL subscriptions is at Facebook. If you use Facebook, you're using GraphQL subscriptions. They power live likes, live comments, typing indicators. If you watch a video and you see streaming reactions, that's all GraphQL subscriptions. And those are just a couple of examples. The current state is that we have officially included GraphQL subscriptions in the GraphQL specification itself. We've added it to the reference implementation, and we also have support for it in Relay Modern. We have some community support for GraphQL subscriptions, both on the client side and the server side, from our partners, Apollo, GraphCool, and Scaffold. I'll have links for those in the resources slide. So here it is. If you want to take a picture of anything, this is it. This second to last link is the Apollo Dev tutorial for setting up GraphQL subscriptions yourself. And if you follow that, you can build something very similar to this very quickly. Is this timer, do I have a couple more minutes for Q&A? We good? Okay. So question over here was reactive databases. Why do we need this notion of a domain-specific event when we can use a reactive database and execute a live query and just have the database push us updates to anything, right? And I think that's a really good question. RethinkDB is awesome, by the way. I like using it too. So I wonder the same thing myself. And I think there are a couple of answers. The first is that if you get to really massive scale, RethinkDB or another reactive database might not be the only data source anymore. You might have a polyglot backend, whether you want it or not. And parts of that backend might be reactive, but other parts might not be, right? So imagine you were building one of these GraphQL APIs and you wanted to execute a subscription, and you wanted to say, give me the weather for surfing spots along the beach. And I want to know whenever the conditions change, whenever a place closes or opens or something like that. Part of assembling that data might be that you want to get weather information, but you don't have that internally. You call out to weather.com or something, and that's an HTTP request. So your data isn't even persisted in your backend. You have to actually reach outside of your network to get it. And you have to join that with reactive data that does come from RethinkDB. So if that were the case, how would you know that? You wouldn't be able to refresh the data. You wouldn't be able to publish to the subscription unless you knew explicitly when to publish, which you can't explicitly know anymore because not all of your data comes from a reactive source. Right? Now, if your data can be in a purely reactive database, then great. And for those of you, how many of you are familiar with Meteor? Yeah, so you've probably seen something like this from the Meteor side, right, where they tail the Mongo logs, and they can detect writes, and they can execute these kinds of live queries. And if that satisfies your product requirements, then awesome. If, on the other hand, you are dealing with a polyglot backend and you can't determine that kind of data change so consistently across the board, then you may want to consider explicitly modeling these things as events. There's another piece, so that's the technical side. But there's another part of this, another reason why you want to consider subscriptions and domain-specific events, even if you're living in this beautiful reactive full-stack world. And that's that the semantic reason of why the data changed is actually valuable to the client. So imagine that you are building a chat room, and you have a list of users that are in this chat room with you. And this list changes as other users log in and log out, right? Well, you could do that in two ways. One, you can execute some sort of living query against it and just say fetch all the users if you have a reactive backend like Rethink. And let's just assume that you're not using this through GraphQL yet. But if you observe a live list like that, at T0, you might notice that it has 4 entries, 4 users in the room. At T1, you have 5 users. What happened? What obviously happened? Someone joined, at least someone. Okay. How would I know for sure? A diff, a client-side diff is a common way, right? So the data can change in ways that you on the client need to be aware of. And you are now coupled to the ways in which the data can change, which is a very interesting type of coupling that I have not seen scale very well. But when you build it with a subscription, some notion of a domain-specific event, imagine you have a subscription that just tells you when new users join. And every time a new user joins, it includes just as a payload, just that one user. Now your job on the client is a lot easier, right? You don't need to diff this list anymore. And I just mean to illustrate that as a trade-off. I think that a full reactive stack, live queries, they're great in a lot of cases. And subscriptions, you'll find that I think there are a lot of scenarios where knowing why something changed is also really valuable, and you don't necessarily want to go through the act of trying to play detective on the client and figure out why something changed reactively. That said, we do have this notion of GraphQL live queries, which is exactly what you're describing. Instead of executing a subscription, you just take a normal query like we had at the very beginning, and you decorate it with the @live directive. Now, this demo is not configured to do that, but that's something that we're working on really hard, and we're going to be talking about it more at the GraphQL Summit in late October in California.
That's not a part of like Apollo or anything, or like the spec yet.
That's right. That's not included in the spec yet. We've talked about it in the GraphQL Futures repo, but it's something that we're still rapidly experimenting with, and we're still trying to build out. Another question right over there behind.
Is there some kind of a way to make sure that high velocity events doesn't kill your server, so it won't make the submission? Is that built in?
Awesome question. So we saw that it took a long time for my subscription to bootstrap because we had so many publishers, such a high volume, right? And this is a really important consideration when you take GraphQL subscriptions to scale. If you had a chat room situation, then you have an n-squared fan-out problem, right? 100 users, all publishing 1 message per second, has to fan out to 99 other users. So you can calculate the flow rate of that problem. And already, even at 100 users, you have a pretty big problem. You're using a lot of bandwidth to fan out that traffic. So what we do at Facebook is that we have pub subsystems and event systems that are designed to throttle this traffic. And we're designed to do it in a way that the product team has complete control over how it's being throttled. So for example, if you open a live video and you're watching, let's say, Beyonce, and there's 50,000 people watching this live video with you, if everybody published messages and we showed everybody else those messages, first, it's a really hard problem. We have that fan-out problem. Second, do we even want to do that? Is that a good experience if I send you thousands of messages a second? We're using all this mobile network bandwidth. We're using the compute to re-render everything. We're using storage to cache these things. Is that even valuable, though, if this thing just scrolls by so quickly that you can't read any of them? So we find that, especially if these subscriptions result in view changes that the user is consuming, a throttle makes sense. It's not a concession. It's something that the product team wants. And so if you want to throttle that thing and say, it only makes sense to show 2 messages a second, at most. And by the way, if my friend is also watching this video and they post a message, I want to see that message at a higher priority than some rando. Right? I mean, That makes sense, right? So these requirements start to enter into the picture when you're dealing with subscriptions at scale. And they're largely served by the event system layer. The event system layer needs to know how to throttle this at both the source stream and the response stream.
All right, unfortunately, I have to end the Q&A there. We're going to move to the next talk, but let's thank Robert again. So 2 more talks, and then off to Lear. I will hand it over to Theo, who is a front engineer at HubSpot. Take it away.
Hi. Is this working? My talk is about skeleton states and how they save the day and look good doing it. My name is Theo. I'm a front-end engineer at HubSpot. And I think I've talked to some of you today. Could you help me out with a show of hands? Who's primarily a front-end developer like me? It's a lot of people at a React conference, huh? How about primarily a back-end developer who works specifically with mobile? Who hasn't raised their hand yet and just likes raising their hand? Oh yeah, well, some people too. Nice, welcome. And who's heard of the term skeleton states before? Some people, but not everyone. So I think we're all in the right place. It sounds like the right mix of the audience, and I hope that by the end of this, we can all raise our hand for a little bit of all of that. The agenda is pretty simple, just 3 things to talk about. First, I want to tell the story for an actual use case of skeleton states that I shipped at HubSpot. Then I want to examine some skeleton states in real products out in the wild in particular. And then finally, we can look at code for a simple implementation of skeleton states. All right, so let's get into it. The story. The story is at work. HubSpot, if you haven't heard, is an inbound marketing and sales platform that helps companies turn leads into customers. And I work specifically on HubSpot CRM, which is a free tool with years worth of complex, nuanced features built in React. And the story begins, like many do, with a message from a product manager. Product managers are the experts in the way that things work, and also the first people to find out when something goes wrong. So when you get a message like this one, and you see that frowny face, that's not so good. You do think about all the nuanced features and the things that could go wrong, and all the different ideas that are floating around. The last time that we get a message like this, we might be thinking to ourselves, oh no, is there a ticket with 14 different use cases attached? Are there 15 different customers that are having the same problem? On this particular day, the next message was that, after analysis of the past 90 days, one single class of issues generated 726 customer support cases. And this is the spreadsheet to prove it that was shared with everyone in the company. That doesn't feel good. We should take a look at this, and everyone's also taking a look at this, so we have everybody's backs. Let's just open the spreadsheet. Let's see what's going on in the spreadsheet. So we pop it open over here, and I want to call your attention right here at the top where it says 726. When we sort all the caseload details over the past 90 days, this comes up. That number includes emails that we received from customers with questions about how to get help or complaints. It includes live chat messages. It includes phone calls from our paid customers that got on the phone to ask for help about this particular class of connecting inboxes. This is the most, not the most by far, but it is the most in the past 90 days. So, maybe we should take a look. Now, we're on HubSpot CRM, so we know that there is a CRM settings page that works exactly with connecting inboxes. It's not the only thing. Like I said, nuanced features. There's other stuff involved. But let's see what we can do. Investigate the settings page. And load it up. Loading. Still loading. Okay, and then there we go. Let's take a look at that one more time. We're going to hit refresh and loading. Nothing's on the screen. Nothing's on the screen. We've got the nav. Nothing. And then everything at once. Users arrive at this page from a lot of different flows. I can tell you it's more complicated than it looks because different stuff can render into that content depending on the flow that the user used to get there. Different facts about the user. We might also have a wizard with multiple steps that takes over the screen. We might also have some modals and sidebars. So it is complicated, but let me point out one thing. Last time I'm going to reload this. Nothing is on the page up until everything's on the page. Hit refresh and nothing, and then everything. This is a symptom of something that's not so great. After investigation, it turns out that there are 5 different APIs, not just 5 different endpoints, 5 different APIs separately authenticated that provide the data for this content. That means that those 5 APIs, our client-side React app is making requests to a server, getting the data back, and eventually using that data as the content for this page. Let's explain this with code. I'll open the source code. It's one of these files somewhere. And here we go. This is actual code. This is actual code from HubSpot. And you'll see this wasn't great. In our component, we have a render function. In render functions, as you know in React, they return JSX to describe what the component is. Down at the bottom, that return value, that looks pretty good. We have our extension sync settings. You can see that's the first row of the settings page. BCC override, blocked IP addresses, lead revisit notifications. That's the right stuff. The problem in this code, the reason this code is bad, is because of that statement. If we don't have the settings data, just return a loading screen. You remember when you saw this page load, there was nothing there except that 3-dot loading indicator, and then eventually everything was there. This code explains that. What's going on in this code is that all those pieces of information coming in from those 5 APIs, they're being stored in a variable called settings in the proper React component. And down there in the render function, we're using different parts of those settings, settings.sync for extension sync, settings.bcc for BCC override. We're using the different parts that come from different APIs and separate components, but we're blocking the entire page until everything loads all at once. Never do this, please. And I know that sometimes we have to prioritize other stuff. Maybe also let's prioritize not blocking the entire page until all the data is there. There are some things that we can do to address this. So let's get back to our PM. We say, I think I know what's up. If any one of the APIs fail, our whole page gets stuck, and I know what I can do about it. I could blame the backend team. I could say, this is a server-side problem. Those 5 APIs should not be failing. Well, that's the easiest answer, and that's frankly what had been happening up until this point. But you know what happens when you always say it's the backend team's fault? One day you get a message from your product manager with 726 different instances of people complaining it didn't hold up. So even though we're front-end developers, not back-end developers, we can still do something about this. One thing that we can do is we can add skeleton states. What do I mean by skeleton states? It's a design strategy. Skeleton states as a design strategy separate the layout and functions of a React component from the data, which is the content. That means that we can populate the layout and functions before we even know exactly what's put there. In this simple example, 3 different pictures of the same component. You can see at the top, that has 2 skeleton states on it. There is the circle, that's a picture, and there are the bars, that's going to be text. On the second line, we got the text data back first. So from the text information, we're now able just to paint that onto the component and replace the skeleton state of the black loading bars with the text that we have. Even though we don't know what the picture is yet, we don't have to block rendering the entire profile card. We can render the part that we have and use a skeleton state as a placeholder for the rest. The reason the placeholder is important is, of course, so that things don't jumble around as you load the page. We want things to pretty much be in the right place by the time that they're painted on the screen and not have to change it too much. And then eventually when the image does load and we're all done, we have that nice component. The way that we got there was very methodologically sound with skeleton states. And I noticed that some people raise their hands, but not everyone in here. The idea of skeleton states has been in use in many different apps on the desktop and on mobile in native. There's a rich history of using skeleton states by different names like launch images, launch screens, interface previews. All that exists, it's written down. We can refer to that literature and learn from it so that we can bring it into our JavaScript apps. One of the ways that native apps lead the way is for the initial experience of opening something for the first time. So this is a screenshot of Apple's official docs, the Apple Human Interface Guidelines for iOS. If you are a native developer, the HIG is a holy book. And this page has been there since iOS 7. We're on iOS 11 now, so it's been there for a while. The text as it currently says in that highlighted blue part, they're telling you, they're stating explicitly, this is a rule that's enforced for apps in the App Store, that the launch screen isn't about artistic expression. It isn't about making something that's unique to the rest of the app. It's about enhancing the perception of your app as quick to launch and immediately ready for use. That's the exact quote from the Apple HIG. It's about making sure that the way that things get onto the screen is separate from other things that are going to be in the content. And the canonical example is opening Safari. So we have a video of that. Let's play. And you can see that we open the app, it's loading in, and then eventually we see everything there. Now I'm going to pause this real quick. Let's try to look at it more slowly. And I just want to call your attention to the idea that when we open this Safari app on the iPhone, at first we see the screen that you see the screenshot of now. This doesn't have all the information. We're not able to render a page because in iOS, one of the reasons why this screen was added as a requirement is because the app isn't even fully in memory yet. The app isn't even executing all of its different parts on this native implementation. The launch image is literally an image. It's a vector image. It's literally an image on iOS. So that's pretty neat. how can we take this information from native apps and read this literature and apply the same idea to our JavaScript stuff? So let's take a look at a React app example next. So this is Slack. And when you're loading Slack, let's start playing this. You see a few different stages of stuff come in, and then eventually you load the entire view. So for that final view, there's a sidebar. That's that purple thing. There's a header at the very top. While we're loading Slack initially, we don't yet have all the data to say what's going to be in the header and the sidebar and the content, but we know exactly where they're going to be. So throughout the process of delivering this information to the user's screen, what the team at Slack have done is say that the sidebar is going to look like this, the header is going to look like this. The moment they have that information, the header comes first, that gets on the screen. And then once they know what your theme is, that you're going to have a purple sidebar, that's on the screen. And then finally, when they have the content, everything else fills in, including the contents of everything else. This is how you can use the native idea from iOS in your JavaScript React app to get that same look and feel, that enhanced user experience. So this is one of the most immediate benefits, is just for the initial launch experience. But skeleton states do more than that. And it is not just for rich interactive apps. It's also for other stuff. For example, you can use skeleton states to hint at what is loading. So this is Medium.com. Medium.com has text content. People use it for a blogging platform. And here, skeleton states are used to indicate what's loading in the stream. So as somebody's scrolling down through this is the feed on Medium. You scroll down to the bottom and they start loading new stuff. So they don't know what's going to be their next that's loading through the network, but we know that it's going to be a story. So they have the placeholder image that they've created where it is a circle, some bars, and then some more bars that generally represents to the user what a story will look like. By providing this hint of the content that is going to be loading, we're able to enrich the user's experience and say what we're going to deliver to them. This makes it feel a little bit better than if it was just a loading spinner or a loading bar, because we know that the experience that we're being provided is exactly what Medium intended. And as we scroll through this feed, I'm pretty impressed that even something so simple is able to give us a better experience through skeleton states. We can also use skeleton states, not just for the initial, but for the middle. So here, this is a screenshot of GitHub. In the pull request experience, we can look at the diff view, and sometimes diff views are huge. So in the screenshot, I've scrolled down to the bottom of one of HubSpot's open source libraries, and that's a yarn lock file. So that is a huge diff. It is a couple thousand lines long, and GitHub says, we have determined that this is probably not something you actually want to read with your eyes. We think it's probably good enough to just say, like, look, there's a diff. And in the skeleton state there, they represented the canonical view of a diff, which is some code that is indented with exactly 2 spaces, not 4, not 8, 2. And that gives us the idea, like, okay, cool, pull request accepted. We don't need to actually look at the diff. If we do want to, we seamlessly replace that skeleton state with the actual diff. We don't reload the entire page. We don't go into an alternate view. We just replace the skeleton state as a loading indicator and a placeholder with the full diff that's there. As the final example, you can also compose skeleton states with each other and use the attention grabbing aspect in order to funnel user attention on the thing that really matters. In this example of a popular cat video site, they've composed a number of states together, and when you go to the page, you immediately get the thing that matters, the cat, and afterwards, second, you get everything else at the same time. This is from the latest redesign on YouTube. I really love that they added this. Look at all the different previews that are built in. We have things like avatars and video thumbnails that are gray until they fill in with the image. We also have more complex things, like spaces where there's going to be a little graph, the thumb indicators, a space for the ad where that might be a different height, and then things like the content and the suggested videos that can actually be swapped into different places. When you look at the network request tab in the browser debugger from the new YouTube redesign, you can see that they're, of course, getting this data from a number of different APIs, more even than 5 APIs. But they intentionally use the skeleton state as a design strategy to make sure that the thing that you want, the cat video, is the first thing on the screen because that's what matters. And then once everything else is loaded, at that point, almost artificially, is when we're able to say, now we can put in the rest. Beautiful. And it also feels crazy fast. So in summary, skeleton states. Native apps lead the way. JavaScript apps, React or otherwise, can get some of the same benefits. And two examples of what you can use skeleton states for are to hint at what is loading right now, or as a placeholder to hint at what will be loading in the future. You can also compose them to funnel user attention on cat videos. I feel pretty good about these examples. I think these are really impressive. What I really want to do right now is critically analyze and just tear into something that is bad, like a really, really bad thing. I'm happy to do that to something that I wrote myself. So let's go back to that settings page. This is the code, the same code that you saw before, and you can see the result of it in the browser window where the whole screen is loading up until it's not loading. And as we discussed, the reason for this is that our render function, the bottom part of it is fine. But when we say if there are no settings, if there's no data from not all the APIs at the same time, we just return a loading spinner. How can we improve this? One of the easiest ways is simply to break apart the dependencies. So I want to point out that in the render function, if you look carefully, you're able to read this code over here. We have return some components. There's 4 of them. Extension sync, BCC override, blocked IPs, revisits. And each of those components has a data prop. That data prop is receiving settings.sync for extension sync. The data prop is settings.bcc for BCC override, and so on. So as you can see, it's clearly delineated. There aren't components on the screen that are sharing data from different APIs. It's really one API provides the data that's used by one component. That means that we can break this down, remove that top part that says that we just display a loading screen, and instead display 4 different loading statuses for the 4 different components that we want. And that's the first fix. And this, as it is already pretty effective. We can view the result of this over here, where we have 4 independent loading things. As we said, we've commented out that first part that displays one giant loading screen. And as data comes in, let's say that first the blocked IP address section fulfills its data requirement from the API. Now we're able to render that. Somebody can fully interact with this on the screen. We're not blocking things. We haven't paused anything. It's React. The React component is in the document, fully interactive, even though those other 3 things are still loading. And when they eventually load in, then people can get to stuff. That number of 726 support cases over a 90-day period, it turns out that of the 5 APIs, one of them was pretty unreliable. Sometimes for some set of users, it just didn't work. That was lead revisit notifications. So this is something that we actually shipped at HubSpot, and it moved the needle in the right direction. For a lot of users, they would visit the page, and whereas previously they only saw one loading spinner blocking everything, now they saw 3 things that they could do, and then 1 loading spinner. Even though that loading spinner never resolved, our users working at companies, they have stuff to do. They have their own fires to put out, they have their own customers that they want to interact with. So it's really important to allow them to do whatever they need to do. In this case, a lot of people just wanted to set the BCC override. Even though we don't know what the lead revisit notifications are, we don't have to interact with those settings just to let them fulfill the use case of BCC override. So this, I think, is, in a nutshell, how to implement skeleton states. If you see anything in your code that says, if there's no data, return a loading screen instead of components, that right there is an indication to you that reliability was not prioritized from the front end. And of course, it's true. This is unreliable because it was a back-end issue. And that is squarely the fault of back-end developers. But we can also take ownership of that. We can share it and say that for the customer at the end, if all they need to do is set their BCC override email address, we can make that happen on the client side even without that 5th API's data. So this is skeleton states, and we can take it even further. So let's look at one more iteration of how we can do this. So that thing, this last piece that's loading, we can make that load in a nicer way instead of just appearing as it did there. So this is the 3rd iteration now of the settings page. And you can see that some things have changed. Let's look back at V2, V3. You see the thing that changed? What happened is in the render function, where we're returning 4 different components, it kind of looks more like it did in V1 now. But we've removed the part that says that if there are no settings data, if no settings data is available, then we're going to return a loading screen. We actually instantiate the components. And the reason why this wasn't done in version 1 is those components error out. They cause a runtime exception that makes our entire thing crash if they receive something that doesn't have all of its data, because we're going to try to do operations like immutable maps.get. And if, for example, on that first component in extension sync, if we pass in settings.sync as undefined, then inside the extension sync component, when we try to do data.get extension settings element, that's going to cause an exception, which is not good for our component. What we did in the third version, the third iteration for the settings page, is we kept our change of not showing a single loading screen, and we actually refactored every single component on the page. We touched every single component that's a top-level child and made sure that it's able to accept data optionally. The default assumption is that in each of these 4 components, the data may not exist. We've recursively applied the strategy that we applied to the entire settings page of making sure that we're able to deal with it if the data doesn't render and have a backup plan. And we've applied that strategy to each of the sub-children as well, every one of those top-level children. So I'm sure you're thinking, how do you do that? Well, it's all about what you want to implement. So let's look at what happens when one API returns data instead of our things here. In our implementation, the button appears when the data is available. Let me illustrate a little bit about one of the components in details. We're going to go all the way depth into one, and it's not going to be too much code. What is in each of those components? You can see that the whole page is all components, so there's nothing here that doesn't come from that. When we see a row that says extension sync, and then there's a help icon, and there's text, and then there's other stuff, all of that is in the component called extension sync. All the stuff that's in the now fully rendered row is in BCC override. And something that you see from our viewing of 3 different iterations of this is no matter what, we have the same text for most of the content. So in our refactoring, the first thing that we've done is inside the extension sync definition. So now this is the definition for that extension sync component, that top one. We've jumped into that source code file and we've refactored it so that it always returns that static text. The highlighted text says extension sync, and underneath there's a paragraph. That is the text content of the row. It's static, and as you can see in our component definition, it's always returned no matter what. Now inside, we're using the same strategy that you saw in the second iteration of the parent settings page, where the data that we're accessing, in this case data.options, is an array that we're putting into a drop-down select, and also a button that triggers the resync thing, which contains data.value. These are things that the component's able to handle for itself. So if you instantiate this component and not all of the props are available, good. The component's prepared for that. It has a backup plan, and it will display that backup plan, which is the text that is static, but not the information that we're not able to access yet. And then when the data is provided, of course, that works. This is for extension sync, which is that first component. We can also jump into the next component down the line, which is a little bit better of an example. So this is now the BCC override section. You can see it uses the same detailed strategy as our extension sync component, where we display text always, no matter what. But something that's unique about the BCC address component is it doesn't just contain a dropdown, it actually contains a button which is the trigger for a pop-up modal, a modal that takes over the screen. So we hide the button if the button's not available, but because we've made it so that all data is optional, we also have to account for every single possible way that this component could receive data throughout its lifecycle. So not just on the initial load, but what happens if we were doing something and now this component is rendered with some parts of the data but not all. We might be able to know that the modal is open through a URL param, for example. Maybe somebody navigated to the page with "is modal open true?" And that resulted in the settings page, us setting the state of the modal open being true. Therefore, inside our inner component, down here at the very bottom line, which is highlighted, that means that that component as well needs to be able to handle data being optional if it's possible for it to be, if it's possible for an instance of that component to be rendered without the data available. Is this making sense? You can see how the rest of the things on this page, which are identical to the 2 things that we just saw, can be fully fleshed out using these strategies so that we have better, more responsive UI for our customers. And finally, we can look at the modal itself. The recursive strategy plays out again. This is the definition of the modal that we were just returning from that very last line. Maybe this is open from a URL param. Maybe this is open because somebody clicked manage. Whatever the case, it is able to treat the data as optional. If it is invoked with props that are undefined data, we're still able to render the component without giving an error, because the definition for this says that we're not going to return things that will error out if we don't have the data. It's very self-explanatory. I think that a theme that you can find with the use of the skeleton state design strategy is these are all simple concepts. This is not mind-bending, really difficult stuff. It is a simple idea that we've carried out and really fleshed through all the different components. And in the case of our HubSpot settings page, it definitely made an improvement. We no longer have the number one thing of customer problems as connecting inboxes. It's pretty close up there, but it's greatly improved. So, in summary, skeleton states is a design strategy that you can use to build React apps that look nicer and feel faster. The way to do that is in 3 different ideas. You have to design an API, you have to design a UI, that puts the right data in the right locations. You can use advanced techniques like composing different skeleton states. You can use simple techniques like using one as a placeholder. Second, you have to have a programmatic way to tell that the data is done loading, which in our code examples we said is merely the existence of the variable wherever it's coming from. And third, you have to have a plan in case loading fails, so that you can apply that plan as the default thing for the component to render. And then when the data is available, that's an optional nice extra where you can actually display something on the screen. The best part about these 3 things is this is exactly identical to a list of 3 things that you would need to do to improve reliability. So when you're talking with your product manager, you know there's a product manager because cats. You can say, skeleton states improve reliability. That's why you should care. I think that is a really strong use case. So please, use skeleton states in your app if you're not already. If you have things that say that there's no data and therefore we're just going to throw an entire loading spinner on the entire screen, I beg you, please prioritize user experience that takes into account that reliability may not work at scale all the time. Thank you. And something that I'd like to ask you is, I'm working on a blog post, so if you can send me your favorite examples of skeleton states. I know you've seen things like this out in the wild. You can tweet at me, TheoPack, or you can send me an email, tpack@hubspot.com. I'd love to take those examples and analyze them for the blog post. Also, by the way, HubSpot is hiring. It's a pretty great place to work. Let me know if you have any questions about working at HubSpot. We're hiring people that have strong JavaScript skills, not necessarily React experience, although that definitely helps. And in all product organizations, including front-end, mobile native, React native, back-end, design, you name it. So just let me know if you have any questions about that. So, looks like we have a question about the content.
More of a comment, but you said that it was the back-end people's fault, but there were 4 teams of back-end groups, or maybe, there's those 4 sections, and the 3 other sections that work blame you as a front-end person. So, it is kind of your fault.
Yeah, true. So the question, if I understood it, is that there are 5 different APIs. So if we were to take the point of view that says it's the server side's fault that one of those APIs failed, the people on the server side on those other APIs are probably saying it's the front end's fault for not being able to handle this when only one API fails. It's definitely circular like that. And that is absolutely a problem if you do have that mindset. I really think that you should not. And I'm glad that at HubSpot, we didn't. And we were able to take ownership in any way that we could as individuals, as individual teams, and make it work once we realized that there was a problem. That's a good point.
All right, let's do one more question, and then we'll swap them.
I was wondering if you could link it back to this morning's topic of server-side rendering. It seems like this is a natural application for using skeleton states for server-side rendering for that preview. Is that something you're doing at HubSpot, or do you have just thoughts on that?
So the question is about server-side rendering and whether this design strategy of skeleton states is applicable. So to my knowledge, I don't believe that we're using server-side rendering of a React app extensively at HubSpot, except for a few specific cases that aren't what most people would consider the app. Something that is really interesting is we do have a React native application that leverages some of the same code in CRM. So for HubSpot CRM, there are places where the same code, ES7 code, is being used in a React Native app and also on the React client in the web. And if you want to use skeleton states specifically, a consideration to remember, whether you're doing server-side or native or whatever, is that the DOM is something that exists on the client. On the server, you don't have a real window document DOM. On React Native, of course, you don't have a DOM. You have whatever the native implementation is. So that's a really big blocker, I think, that would prevent a particular implementation of a component from being usable universally like that. But definitely, if you are able to delineate what is going to be rendered on a server and then what is going to be rendered on any particular client, yeah, you can use a strategy in parts and say, for example, render as much as you can on the server and then return a client that is going to have loading spinners until all of the client-side requests are fulfilled. I'm so glad you asked that because universal apps are kind of cool.
All right, great. Let's thank you again. So while we're swapping computers here and changing the mics over, stand up, stretch out. One more talk today.
Awesome. How's everyone feeling? Last talk of the day? Good? Sweet. All right, so my name is Divya Sasidaran, and I'm a web developer at the Night Lab, which is a little lab that's embedded in Northwestern University School of Journalism. I work with students and faculty to build open source tools and libraries, specifically to help journalists and newsrooms tell more impactful and interactive stories. So some examples of stuff I work on is like charting tools, kind of like what Christina was talking about with D3. I work with D3 a lot. And so if anyone has complaints about D3, I empathize. So because this is kind of an unconventional talk, we're going to start with a little exercise to switch things up and to get us all into mapping mood. So I know it's been a while, but think back to your commute to get here from start to end. And I want you to think about that in terms of the route that you took, means of transportation, and try to think about how you would tell someone who is trying to get from where you started to Wayfair, where we are today, and like what are certain things you would tell them, how would you direct them, and what kind of a map would you use? So I was in Cambridge this morning, and I took the T. So to help someone get here, I would pretty much give them a map of the T, and I'll tell them to get on the red line and then hop on either the orange or the green line to get to Copley or Back Bay. So it's pretty straightforward. The T map is very simplified. All of the stations kind of radiate from the center. All of the routes are delineated by color. So it's really obvious to see where you would get on, where you would transfer, and where you would get off. If I wanted to go one step further, I would overlay that map onto a map of Boston. It's a bit complicated, but it gives you some context as to where stations are relative to each other. So if someone wanted to walk from Downtown Crossing to Park Street, that's possible because the stations are close together. But if they wanted to walk from Porter Square to Harvard Square, that's a bit of a hike down Mass Ave. And so this map kind of gives you that context. So the exercise that we just did kind of gives us an idea of how we use maps daily. And that is, we use maps as maps that are overlaid with data. This is OpenStreetMap. I'm super hipster and I'm all about that OSS, So I use OpenStreetMap. And OpenStreetMap gives you the ability of switching up layers. Google Maps also gives you this, so it's pretty similar. And it allows you to kind of add detail as necessary. So if you're a biker, you can add the cycling map so you can kind of figure out routes to take. And if you want public transportation, you can turn on that map, and so on and so forth. Another map that we might all be familiar with is a weather map. This is specifically Weather Channel's new app. I think it's called Storm Radar, and it allows you to track a hurricane or any kind of storm as it's passing through. And the neat thing about this is you can kind of rewind and fast forward, so it's pretty neat. But what essentially it does is it gives you data that overlays onto a map, so you can make decisions in your daily life, whether you should bring an umbrella, what areas to avoid, and so on. A map that's more first world problems oriented is this timeline map that Mapbox created. It's a bit hard to see, but it basically radiates and shows you food options that are closest to you based on a search criteria. It grabs from Foursquare specifically, so you can kind of figure out if you want sandwich options 10 minutes from you. I think Potbelly is your closest bet. And then it kind of overlays that, so once you make a selection, you can kind of get directions and move on from there. So what all these maps have in common is tiling, and tiling forms the basis and foundation of web maps in general. And Christina talked about this a little bit, but in tiles and in web maps, there's vector tiles and raster tiles. If you've worked with any kind of web graphics, you'll get the difference. But just looking at the zooming in and zooming out of this, you can kind of guess in terms of performance which is a better option. So raster tiles, just a quick overview, is a quilt of tiles. And it's tiles in the very general sense of a tile, and it has data mapped onto it. But it's flattened, so one individual tile has road data, it has park data, it has street data specific to that zoom level. So if you removed one tile, your map is incomplete. And each tile, because it's a flattened image, is specific to that zoom level. So when you zoom in, you request more tiles because your map is more detailed. And then if you zoom out, you request fewer tiles because you don't really need to see roads at a higher zoom level. And so when you request map tiles, this is pretty much the standard for how you would do a request. You would grab a subdomain, and then your tile provider, OpenStreetMap is a very popular one, and then you would give it coordinates and zoom levels so that you know which tile to use. I'm not going to talk about raster maps past this because it's not a common option, but if you're interested in it, I've worked with it with D3, so I can talk about it in the hallway later. So vector tiles is a much more performant approach to mapping, and vector tiles, you can think about it as a series of layers that overlay each other. And so each layer holds a specific piece of data. So one layer has roads, another layer has bike maps, another layer has train lines, and so on. So you can think about it as if you remove a layer, it gives you fewer details, and if you add a layer, it gives you much more details. And so there are various ways in which we can use vector tiles, and vector tiles are pretty robust in a sense. But we're going to be focusing on Mapbox specifically, and specifically the Mapbox GL.js library. Has anyone worked with Mapbox before? Somewhat, maybe. Okay, so Mapbox GL is pretty much the Mapbox API ported to WebGL, so it's like super fast. And so you can do really incredible and intricate data visualizations on top of your maps. So to create a map, you pretty much just create a div element with an ID, and then you pass in the access token to your Mapbox object, and then you instantiate Mapbox by passing it in the container, the zoom level, you center the map. These coordinates are specific to Boston because we're in Boston, and so on. And so with that, we kind of have like a very basic map, and you can zoom in and out, which is pretty neat. And so this is just a canvas element that it renders out to. And so this map is super basic. It doesn't give us a lot of information. It gives us a sense of like the city of Boston, but it doesn't have data on it. So let's go one step further and try to add some data. So adding data in Mapbox and Maps is using GeoJSON, and that's the standard. It's super similar to JSON, but it's a bit more strict, so I guess it's not like JSON, because you need the type feature and the features. You need types and features, and type is basically always going to be pretty much feature collection. You can think of it like an array of features, which is what the features key is, and then you pass in like data specific to what you want to map. Here, we're just giving it a single point, and the longitude and latitude is just Wayfair, and that's like pretty much it. It's very simple. And GeoJSON, because it's very standard, you can get it on most websites. If you go to your local city's open data portal, usually you can convert to GeoJSON. Sometimes they'll give you shapefiles, because generally when cartography is done using ArcGIS or QGIS and so on. So in those events, you kind of have to work with other tools to convert it. GDAL is a really popular one, and I've used it extensively. Leaflet has this thing called Omnivore, which is just a collection of tools that allows you to do conversions. And if you're interested in learning about that, there's like a little link at the bottom. It's really small, but it's a gist of like various tools that you can use for conversions. But we're going to assume that we already have our GeoJSON. So for the first mapping feature we're going to add to our map is just like a little star icon that shows us where we are. And in Mapbox, adding data is as easy as just adding it as a source. So we added a source after we load the map, because the map has to exist in order for you to add source. And then we pass in the data, and it's of type GeoJSON. And then once we create that source, we now port and connect that source to a layer. And we use the method add layer, and we give it the source ID that we created. So in add source, React Boston is the ID, so it's the identifier. And then in add layer, in source, we pretty much map that directly to the source so it knows exactly where to get that data. So, so we have a feature, hooray! It's very simple and it works, but at least it shows us exactly where we are. So a key feature in Mapbox, and a really important part that I mentioned a little bit earlier, is this concept of layers. And layers hold data, but they also are in charge of styling, so you can style layers differently, and you can add events, so layers respond to specific events that happen on a map. So here, I'm having the exact same map that I had previously, except I'm adding an additional layer of information. So we have a little star icon that shows us where we are, but I overlaid it. Can everyone see this? Okay. There's like a little shape file or shape of Boston neighborhoods. So you can see where we are relative to the other neighborhoods within Boston. And so that source is the neighborhood's GeoJSON object. But the way we're visualizing it is in two parts. We're visualizing it as a fill, and we're visualizing it as a border. So a single source has multiple pieces of data, and we're visualizing them differently using different parts of the layers. And so we add that single source. It's like a GeoJSON object. It's really giant, so I'm not going to show that to you. But we add two layers. We add a borders layer and a fill layer, and then we style them appropriately. Ta-da. So now we can go and add that. We can add events to maps. And the nice thing about Mapbox is you can kind of like have different parts of your application impact what happens on your map. So when I clicked on the checkbox, I was turning a layer on and off. And so that's pretty much just an input, like an add event listener on an input. So when that input gets toggled, my layer gets toggled. And Mapbox has this specific method called get layout property and set layout property that allows me to get the current style of a layer and then set it appropriately. And the reason for that, like Christina mentioned, is that Canvas itself is really difficult to kind of query. You have to go multiple layers deep, but Mapbox gives you an abstraction, and so you can kind of use those methods to query specific parts of your map and figure out how to style them appropriately. So now that we have figured out that there's those very basic events, we're going to add like another layer of events on top of what we talked about, which is just like a hover layer. So it kind of shows you a more interactive way of working with a map. So not only now can we visualize the neighborhoods of Boston, but we can kind of hover over them. And we can click on them, and it shows you in this tiny little box like what exactly that neighborhood is. And so you can kind of interact with the map a little bit more instead of what we were doing previously, which was a little bit more static. And so this is a bit of like an additional layer on top of what layers can do. Layers can be conditional because, as I said, layers get data, and so layers can kind of decide what to do with that data. So styling is one way of how you tell layers to present that data, but filters is another way that you can kind of tell the layer to handle specific pieces of your data. So what I mean by that is, let's say we have like this add layer and we're just giving it a filter. Just think of it like an equality check. So it's equals equals, and then we give it the property of name, and it's empty, so the layer doesn't show. It's not visible. But then on mouse move, so like when the mouse moves into the fill, we're setting the filter to be that specific feature that we're hovered over. And so the filter that is being called kind of checks that specific feature against that entire array of neighborhoods feature, and it's like, this is the feature you want, and it shows just that feature. And then it unsets it when you mouse leave, you have to unset it so that the layer is no longer hovered over. So it's an additional layer that we can add on top of our interactions. So if we look at kind of what we talked about so far with Mapbox, it gives us a lot of flexibility of adding events, adding styles, adding event-driven styles, and data-driven styles. And that itself is it adds a huge cognitive load for us developers, because we have to remember the state of our layers, we have to remember what layers are handled by what event, and so on, which is kind of where React comes in, because React allows us to compartmentalize and componentize specific parts of our map, so we can think about them in pieces rather than as a whole collective. So we're going to dive straight into components and create a map component. It's just a single component of class map. And we'll just throw what we did with instantiating a new map, we'll just throw that into the component as is. But one thing I want you to note is that, remember how Mapbox requires a container? It requires you to tell it specifically where to put it. So in this case, we have to have Mapbox instantiated in component did mount, not component will mount, because we need the render call to be called at least once. So at least it's able to know where exactly it is in the DOM. And we need to go one step further by giving it a context, because it doesn't know exactly where that DOM node is. So we add in a reference so it's able to kind of connect itself to that DOM node and then act appropriately later on. So we effectively have a map, which is exactly what we wanted. But let's start by adding that layer, because it's not interesting just as is. So we'll dump that add source and add layer, like what we talked about. We'll just dump that into add layer, into the class, and then we'll effectively have a map with a little star icon that shows us where we are. So again, super basic, but we're React developers. We componentize our components, and we componentize those componentized components. We like to kind of break everything down. And so let's try to extrapolate the layer element so it lives on its own. So what we'll do is on fetch, assuming that we're fetching data from an API, we're just going to set the state. And then we'll pass that state onto the layer as props. And then the layer itself knows exactly what to do with that because it grabs those props and then it sets the data appropriately using add source and add layer. The other piece that's important to note is because we're writing to Canvas consistently, the render returns null because you're not writing any DOM nodes, you're just writing directly to the Canvas element. But then we hit a bug because map is not defined. So our layer or our add source, add layer didn't work. And that's partially because layer was trying to render before map was even set. And so what we need to do is we have to force layer to wait for map to exist on the page before it's able to do any manipulations or any data showing of data. So that's what we're going to do. We're going to use map and to make sure that map exists, and then layer gets rendered. But again, we're hit with another error because add source is not a function, which is annoying and horrible, but there's an easy fix. What we need to do is we need to pass context because add layer lives completely separately. It's a separate component, so it's no longer within the context of map. And so we need to explicitly tell layer where exactly to get that context so it knows what exactly map is and what exactly those methods associated with the Mapbox object is. And we do that through prop types. And that's pretty simple and basic. We pretty much set the prop types in the class of map, and then it's available as context. And so any other subsequent children of map has the ability to query and use map. So with that, we have a working map. Hooray. So again, we created a layer effectively, we visualized the layer, and we have a map that works. But again, the layer that we have is pretty much hard-coded at the moment. And so if we were to create additional layers, we can't because it's pretty much all of type symbol, of ID, React Boston, and so on. And so let's extrapolate those pieces so that layers kind of live separately and we can create different layers of layers. So we'll extrapolate the ID, the type, the source type, data, and styles, which are pretty much just the elements that you need to pass to add source and add layer appropriately. So again, now we have an element that it lives pretty much independently, and we don't have to rely on like each layer pretty much is independent of each other. But the thing is, now layer, source is hard-coded into layer. And so the example we talked about previously where we had two neighborhood elements, a fill and a border, need to pull from the same data source. And so if source lives in layer, another layer can't query that layer's source because that's extremely inefficient. And so what we're going to do is we want to extrapolate data away from the component as much as possible. And so what we'll do is we'll create a source element, and we'll give it an ID and a type and a data, which again are just features that we add to add source. It has an ID, it has a type, it has a data. And then we pass that appropriately, and then now we have a source element that layers are able to query from and read appropriately. So currently, we've created a map. We've componentized every part of the map. We have sources, we have layers, everything works, but everything is still static. So one thing that's really neat and makes maps really cool is the interactive element to them. We want to visualize data, and we want people to interact with that data that's visualized. So let's talk about life cycles. We're all familiar with mounting, updating, and unmounting. We talked a little bit about mounting with component did mount, but we're going to focus on updates because that's where the magic happens. And so we're going to create a little dummy app where we have a checkbox that makes a layer visible and not visible. It's pretty simple. It's exactly what we did earlier, the example that I showed you. And I'll show it to you again. So we have two layers, and then we have a checkbox that turns each layer on and off. Pretty basic, nothing too crazy there. I'm not going to go into what checkbox looks like because we've all probably created checkboxes in React at some point. But what I do want to focus on is that there is the method show layer that checkbox calls when any change happens. And so it kind of propagates that method to be called. And then, or it bubbles up the event so that that method gets called. And then that method sets the state for whether a layer is visible or not visible. And then the layer takes that in, and then it sets that layout property to visible or not visible. So that's pretty much what it looks like. That's not what I wanted to show you. So again, if we look in the layer itself, we're going to use component will receive props. It gets called after render and when updates happen. So if props change, then that method gets called. And so we're going to check, because we want to check the property of is layer visible. Because, I mean, we're future thinkers. We think that in the future we'll have different parts of the app that changes. And so for now, we're going to just check that is layer visible changes. And so if the next props of is layer visible matches or doesn't match in this case, the previous is layer visible, then we set and change that so that the layer becomes visible and not visible and visible and so on. Where the meat and potatoes of this whole like component will receive props is, can people see the little bike, the tiny little one? Okay, cool. So this is a visualization I did where I pulled the Hubway data, and I kind of like, I had to do a lot of data munging, but I pretty much grabbed the Hubway data and then pulled a single trip, which is a start and an end, and then Turf.js, which is a library that does geoanalysis, allows you to kind of figure out the distance between the two. And Mapbox has this thing called turn by turn that basically takes two geographic points and then it straightens the lines out based on roads in the area. So you can tell, like, based on a start and an end point, you can give it a path to take. And then all we're doing in React is we're just setting the data. We're just setting it and updating the data, and the layer is changing appropriately. So component, I won't go into the details of how I did that. I use request animation frame. So if you're interested in that, I'm happy to talk about it. But for now, there's a lot of math, so I won't go into it. But we're just checking in the source element itself to see that data has been updated. And if data has been updated, then it basically grabs the source and then it updates the source. And layer, because layer gets re-rendered, layer pretty much knows to style it appropriately and change as needed. So what all of this means is that Mapbox is really good at what it does, because Mapbox was built, and Mapbox GL.js was built for the purpose of creating very robust interactive visualizations. But over time, it gets really difficult to manage, and that's where React comes in. And so if you bring the two together, they work really well, because React does rendering so well, and pretty much it allows you to handle state in a way that you as a developer don't have to think about. You can bring Redux in if you really want to. I personally have never found a reason to use Redux because a lot of the state management that happens on a map is not that complex, really, if you think about it. But in a way, the two work really well together. And so what this essentially means is that this, as an example, kind of shows you that most libraries out there are pretty extensible and they work really well with React, because React kind of gives you the ability and flexibility to work with the DOM and work with events. And then those libraries that does charting, kind of like D3 or Mapbox, can kind of do the math and do the like calculations necessary and then pass that on to React. So that's all I have. I have some links to things that I talked about. I also have like a bunch of CodePen pens if anyone wants to kind of get into the code and see what I worked on, but that's all I have.
All right, I think we're going to save Q&A for the bar because it's been a long day. So a couple details about the party because we're going to go straight there. The party is sponsored by Pluralsight. If you're not familiar with Pluralsight, it's an online platform for learning and testing your knowledge. I'm actually a Pluralsight author. I have a couple courses on PHP on there, so look me up and watch those if you want. I get a few royalties from that. If you're going to the party tonight, you will need your badge, so bring your badge with you. It is an open bar, beer and wine, unlimited consumption, but take it easy because talks do start tomorrow morning at 9 a.m. The other downside of that is that we just learned Lear will not admit anyone under 21 years old. So if you are under 21 years old and you were really hoping to go to the party, come find me and we will take care of you. We'll have plenty of food, plenty of beer, plenty of wine. If you go down to the Sky Lobby, we'll have people in blue shirts that will lead you to Lear. It's also pretty easy to get to. You're going to go through the mall, across the Sky Bridge, through the Prudential Center, take a right, cross the street, and you're there. Very easy. Google Maps will find it for you as well, or follow people in blue shirts. That's it, and we'll see you at the bar.